Well, welcome back, folks. We talked over the last, I guess, hour and 20 minutes about the applications of FDO in the real world with Exxon. Microsoft have told us about how they're using it in their Azure Edge solution. We've heard about Red Hat's application within their RHEL products. But people, I'm sure, start, and of course, ASRock talking about the support of their solutions. But people often ask, kind of, what now? Is basically FDO reached a point where it's just stable? We're done. There's nothing more to discuss. And the answer is, well, it's certainly stable. It's certainly usable. You've seen that from the previous presentations, but it is also very much evolving and moving forward. And as you're going to hear from Brad Goodman, who's our co-chair of the technical working group for FDO, and with Dell, he's a principal engineer at Dell. He'll be talking about the future of FDO and where it is today and where it's going next. So with that, Brad, thank you very much for joining us, and over to you.
Hi, so as Richard said, I'm Brad Goodman. I'm with Dell Technologies. I'm an architect in our Edge division, a product called Native Edge, and also in a evolving thing called Dell Solutions Platform, which is kind of expanding on some of our Edge technologies into other cloud data center, AI, and other use cases. As you probably know, but I always start with conversations about FDO, saying that FDO originally started as kind of an IoT-centric technology. Right now, we're at version 1.1 of the specification, and that's been out there for a while. And our MO of leaving that to be there for a while and to have it be stable is to give people the understanding and the confidence that this wasn't, wildly in flux, that it was stable, that it was dependable. So we've had 1.0 out there for a while, and now companies like Dell and many of the others that are on the presentation today, they're not IoT companies. They don't make little IoT devices, but they work in more general purpose computing. And so FDO, as something that came from the IoT space, needed a little bit of evolution in order to kind of tackle some of the bigger federated enterprise type use cases that companies like Dell and others are targeting. So FDO 1.2 is bringing a big piece of functionality called delegate certificates, which is basically kind of a TLS-like methodology by which we're able to onboard devices to larger federations of control planes, distributed control planes, multi-regional control planes. So it's targeting some more of these enterprise type of use cases, including enterprise edge use cases. And there's also been some work being done with the Wireless Broadband Alliance, using and leveraging some stuff with FDO in their open roaming specification. FDO obviously, again, roots in IoT, and the main purpose of it being to have a device in the control plane and to have a way to provably interconnect these things together, and then to get out of the way and to be able to interoperate devices in steady state. And this is kind of predicated, if you look at it from an IoT perspective, on the fact that these devices, when they come out of the factory, even though we want to late bind their credentials, their personality, their purpose is somewhat rigidly defined in the factory. It's an IoT thermostat, it has a temperature sensor. It knows how to connect to a control plane and to give temperature readings or to change temperature. So the personality and what that device is fairly rigidly constructed in the factory. But when we get into the concept of general purpose computing platforms, commercially available off the shelf ones, i.e. these are not little IoT embedded devices, but these are things that I can put my own software on, I can put my own applications on, I can put my own operating system on. In order to do FDO, that kind of inherently means that I need the FDO software. I need to take my application, I need to put my OS, I need to stage this in manufacturing, and then I can ship these things out and late bind them. But I need to establish the software and the personality in manufacturing. So obviously there's time, there's cost, there's effort. if you wanted to adopt a model where you want to, put these things through distribution or through other warehouses, and you had different devices that would need to have different personalities, you would need to put other SKUs into that distribution channel or that warehouses. And a lot of people with FDO, they understand the concept of late binding, and they understand the concept of being able to turn it on, to connect to the control plane, to understand that. But it's often, I would say misattributed or misconstrued as being something that can take the device and assign it that personality dynamically. When we talk about late binding in FDO, we really talk about the credentials, we really talk about the control plane. But what we don't talk about is the software on that platform. So today, even if you want to do FDO, you're producing a device, you're putting your OS, your applications, your FDO client on there, and now you can turn it on in the field and onboard it into the control plane via late bound credentials. But the real goal, or the real thing that people seem to always want, and Dell is definitely in this case and aspire to, is the idea of being able to turn a device on a general purpose off-the-shelf compute platform, and then to use a process like FDO to dynamically in the field not just late bind the credentials, but late bind the personality of the system, late bind the operating system, the applications, the configuration, and more than that. So there are a lot of technologies out there already to do bits and pieces of this. Everything from Pixie Boots to iPixie to things like Kickstart and Cloud Init files. There are hardware systems like BMCs. Dell has like an iDRAC, which is kind of like a BMC on steroids. And these are all tools that are out there and methods to tackle this in bits and pieces. And how you could use and apply these tools will also differ with even like the operating system you want to put on there. For example, some operating systems like will support Cloud Init and Kickstart files, and granted they have dependencies on block devices and file systems to specify the Kickstart file, which may or may not be available on the hardware platforms. There is other things like, I believe OpenShift works like this, and I know Raspberry Pi looks like this, is they have sort of like an imager utility, which will allow you to take an installer image and kind of bake your configuration into it. So now you can send that over in one shot, install it. So there's all these bits and pieces of technologies to allow this, but there's no commonality, and in many of them, there's not really security. Like, it can network boot an image, but there's nothing to prove that, that network device was in fact authenticated, that the image that was installed was really the desire, especially when we start working not with on-prem networks to do this kind of bare metal orchestration, but the desire of being able to take a device like even my laptop, ship it to an employee, turn it on in the field, and then have it dynamically use a cloud service that it now needs to establish trust with in order to install the image that my corporation wanted to put on there, and not knowing any of the final disposition of this when it left the factory. So not even to be able to bake in the credentials of who my owner is, let alone what the wishes of that owner should be. So the aspiration really is to find a way to unify all of these, and but yet not to reinvent the wheel. Like, there are mechanisms out there already. We want to use those leverages. We want to leverage those mechanisms, but we want to fill in some of the gaps to make it work across all operating systems, to make it work across many different applications and solutions, and from many different hardware vendors. So the panacea, would be that I can buy a system from Dell or Lenovo or whatever that has this FDO enablement, and to be able to turn it on and for it to figure out, even though it had no specific configuration coming out of the factory for it, like we do for late bound of credentialing, but we can use FDO's concept of ownership vouchers and proof of ownership to establish, proof of what the software image and the configuration on there should be, so we can get the real panacea of dynamic, proven, late bound setup and configuration of the system. And I wrote kind of what I was trying to establish as a pithy kind of mission statement that went on, but I'll read it to you. It was establish a universal, unified, widely adopted, standardized way to achieve late bound bare metal onboarding, installation, and configuration of general purpose off the shelf, commercially available compute devices from standard or customized install images. So that's a very long mouthful of a mission statement, but that is sort of what we're aspiring to do. And again, the shorter term goal is any FDO enabled device from any manufacturer, and now I can have an operating system installer image and can more or less late bound say, this is the image that I want to install this is how I want to configure this. I can prove cryptographically that I am the owner. I can embed my wishes into this so-called manifest, and that we would use lower level mechanisms, like, for example, and I don't want to get into implementation details, because what we really want to do is just kind of address the problem statement at this point, but is use something that can be very common coming out of the factory, like a BIOS, like an UFI, like some sort of, I don't want to say PXE, but pre-execution environment that can be commonalized and use across multiple OSs, multiple distributions, even allowing end users to specify what they want on the machine when it boots and late binds and onboards, or a manufacturer to specify that I'm selling this system. Maybe I want it to run Windows, maybe I want it to run Ubuntu, or even something like VARs or resellers who can say, I want to, for example, buy a Dell system, have it drop shipped to my customer, but then for it to be late bound and have my application and distribution put on there as part of what's going to happen in the field. So any vendor off the shelf FDO enabled hardware, any OS off the shelf FDO enabled installation packages. So that's kind of the mission and the goal behind our initiative of late bound bare metal installation. And we, as the Alliance and as the FDO Technical Working Group, are trying to work and talk and solicit with other people their interest in this, their participation in this, and agreement on the problem statements and how we might jointly tackle this. And that is basically all I had today. I'm off on my slides, but my talk track never matches the slides. Sorry about that.
Thanks, Brad, very much. And I hope everyone found that particularly interesting, because as I mentioned at the start, we often hear about where FDO is in terms of the specification, but I really wanted today for people who are joining us to understand where FDO is going, not just as the onboarding specification, but this evolution into bare metal onboarding. And with that, we're going to take a very short break, and then we're going to rejoin with the panel, and it will be an opportunity for folk to ask questions. Some people have been popping them in the chat window. I'll read out as many of those as I can, and then I've got a few prepared questions as well. So join you again in a minute.